In this example, we'll go through and show you some of the new volume rendering capabilities in EnSight 10. We have a relatively simple duct model. Air comes in through the duct on the left, entrance on the left, but it does have to both expand and turn 9 degrees fairly quickly. So there is quite a bit of separation and complex flow features going on behind this turn. And we'd like to try to understand that in a volume sense. If I show you what a clip plane looks like, you can see a little bit of the non-uniformity in the flow, but it's really just looking at a particular plane, and I can make other planes that might show it a little bit more or less. I could even turn on a ISO surface part to try to understand the flow, but again, I'm only really looking at a single value at a time. And this is where volume rendering comes in. So what we're going to do is we're going to select the fluid that we'd like to render based off from a variable. So with that part selected, I'm going to select on the element representation. I'm going to change it to volume. This new window will pop up in EnSight 10, which has the ability to do both unstructured volume rendering as well as structured volume rendering. The structured part is new in EnSight 10, so let's go through and see what this does. We turn on the structured box clip, and we specify the resolution that we'd like to have in each of the X, Y, and Z directions of the box. I'm actually going to put in 128 by 128 by 128. You can choose different values based off your graphics card, the amount of memory that you have available, and so forth. We're going to choose the variable that we're going to render by. So in this case, we're going to take velocity and render each element based off from its velocity, and we're going to change its transparency based off its velocity value. We'll show the palette tool once we're done here. So we'll hit OK. EnSight's going to use a structured volume rendering technique now. We're first going to map the data from our unstructured model into a structured IJK, which has a resolution of 128 by 128 by 128. And then for that particular volume, we're going to then render each element in that volume based off from its velocity. And we'll change the transparency in that element based off the transfer function between velocity and opacity. When this comes up, again, we can change those values around based off how much graphics capability you have in your particular model and how big your model is. So it's quite flexible to be able to utilize this on different models and for different uses. Okay, now this is up here. We're going to let's first take the wall off from here, and we're going to turn off the box tool so we have a slightly better picture of our duct. Now at the moment we're using a constant transfer function, so everyone has the same transparency. And this transfer function is presented here in our advanced toggle under the palette editor. Here we can control the transparency, so if you think about this vertical axis going from 0 to 1 for opacity, and the horizontal axis being our velocity range here. So let's actually take and make something in here slightly more opaque. So now we're basically highlighting this portion of the variable field. You can see up here we've got an RGB and an RGB times alpha scale up here, so we can see what's going on a little bit easier. So you can see that items in here are going to be very opaque, whereas items down here are going to be very translucent. So elements with velocities in this range will be very translucent, whereas elements with this velocity in here will be not only opaque but also this blue cyan color, and that's what we're kind of highlighting here. So we can use this transfer function to really start to highlight different regions of the flow field. And this is really the benefit of volume rendering, is that we can now render and look at a particular region of our model based off from velocity, but still be able to see everyone. So for example, let's not accentuate that region. And maybe really only want to look at the regions where we have kind of low velocity. So again, we can move these around a little bit and perhaps pick up an area which may be more important to us in this region here. One common attribute here is to do kind of a sawtooth effect, where we get different gradations of light and dark, sort of bright and dark, I guess, also based on the colors. So we can now have a slightly better, more informative view of our whole model with this variable, and we can see the influences of the low velocity region swirling around this sort of high jets in this sort of green area, probably 6 meters a second or so, and this region of low velocity here around the outside. And we can kind of get a much better feel for the three-dimensionality of that velocity field using volume rendering. Again, we can go over to our options tab. We can use an alpha scale where we can sort of raise up or decrease that sort of scaling factor for the actual transparency. So that's basically scaling this value up and down. And we can change the range around here as well. So if we bring this down to, let's say, 5 meters a second, this is now applied all based off from 5 meters a second, 0 to 5 in our velocity stream. So everything that's red now is 5 or above. And we can certainly restrict this down to look at different regions. In this case here, we might want to make this opaque. We might want to make some of the other values down here very, make these other guys very opaque, make the higher guys translucent in our model. Okay. So again, we have the ability to go through and start to accentuate and highlight different regions of our variable field based off from volume rendering, and the new volume rendering capabilities in EnSight 10, which again are based off from using the element representation and looking at a structured dimensions here that we can control for any model and be able to control the resolution of that volume rendering so that we can do this volume rendering on any particular model that we have.